at number 5. Number 5, you are doing solving systems still, but it's a word problem. Put your phone away. With word problems like this, you have to set up the system and then you have to solve the system. There is a question nearly identical to this on the written portion of your final. So if you don't know how to do this with me right now, communicate that with me and we'll make sure you get it. Yes. Number 5. Okay. But this is like a 4-point question because you have to be able to set up the system for me and then you have to solve the system for me. So this is the big one on your final. Maybe put a sample of it on the note card or give yourself some little pointers so that we get it. All right, so I'm going to read you the question. I'm going to see if you can set up a system for me. It says, Brianna bought 3 bottles of ketchup and 2 bottles of mustard for $11.85. Logan, hey, that's you. I didn't do that on purpose. This is actually an old question. Oh, no, it's not. This is a pre-made question. Logan bought 2 bottles of ketchup and 5 bottles of mustard for $13.73. Set up a system of equations and find the cost of each, meaning find the cost of a bottle of ketchup and find the cost of a bottle of mustard. How many equations in this system? 2. Okay, so see if you can write 2 equations right now for this system. Go. Okay. Do you think you have it? So I'm saying K is ketchup, and I'm saying M is mustard for mine. Okay? What would your first equation be? 3 bottles of ketchup, 3K, 2 bottles of mustard. Okay, costs $11.85. So that's one of your equations. The second equation, what'd you do? 2 bottles of ketchup plus 5 bottles of mustard, 2K plus 5M equals $13.73. Did you get that? Okay, so that's 2 of the 4 points for this problem, is can you set up the system? So that's your system. How do you solve this? Elimination or substitution. What do you prefer on this one? There's definitely, in my head, there's definitely an easier one here. I would say elimination is easier because substitution is going to get ugly because you're going to have to divide by a 2 or a 5 and they're not even numbers or they're not divisible by 5. So I would do elimination. You don't have to, but I'm going to because I think it's easier. If we're going to eliminate, do you want to multiply one equation, both equations? How are we going to do this? It has to be both, okay? In order to eliminate, we got to make them opposites. What do you want to multiply the top equation by? I would do 2. I would multiply the top by 2 because that's going to give me a 6K, a 4M, and 2370.
Is this the same setup as the ones we did yesterday?
Yeah. Okay, so my K's now, I have a 6K. So what's the goal on the bottom? To get a what? To get a negative 6K. So how can I get a negative 6K on the bottom? Multiply by a negative 3. So this is a negative 6K, a negative 15M, and then 1373 times negative 3 is a negative 4119. Okay. Are you with me on that so far? Okay, so what's your next step? Add them together. If we add these together, it's going to eliminate your K's. 6K minus 6K, or 6K plus a negative 6K is 0. 4M plus a negative 15M is what? Negative 11. Just plug that into your calculator. 4 minus 15 is a negative 11M. Okay. And then 2370 plus a negative 4119 is a negative 1749. What's your next step? Divide by a negative 11. And you get 1.59. What does that mean? It's $1.59 for a bottle of mustard. Okay, mustard equals $1.59 per bottle. Are we done? No, what do we got to find? We got to plug it back in so we can find the catch-up cost. You may plug it in to any of these four. You can do the purple here, the green, the blue, or the pink, and it will work out. I would probably do, well, what would you do? Purple. I would probably do purple. So I'm going to plug it into this equation. So it's going to be 3K plus 2 times 1.59 equals 1185. 2 times $1.59 is 318. So 3K plus 318 equals 1185. And then we're going to take away the 318. So you get 3K equals 867. And then divide by 3. And you get 289. Okay, so that means a bottle of ketchup is $2.89. A bottle of mustard is $1.59. Make sure you label with dollars there. We're talking money. What does it cost? So make sure we know it's a cost. Okay. Any questions on that? Yeah.
Well, I was gonna ask how much time we have for the final.
An hour and a half. Yeah. Okay, graphing systems and shading. This is the fun one, right? Do you remember doing this? You get to like shade it all one way, shade it all another, see where they overlap. It's beautiful. So the first thing we're going to do is we're going to graph them like they're a line, like they're an equation. Y equals negative 3x plus 5. So if I'm going to graph this, I'm going to do this one in green. How do I graph that? Where do I go first? Up 5. So this is your y-intercept of 5. 1, 2, 3, 4, 5. Don't throw things. From there, where do you move? Down 3 to the right 1. So you're going to go 1, 2, 3 down, right 1. I'm going to go again. 1, 2, 3 down, right 1. You don't have to, but I like a nice straight line. Can anyone tell me, is this dotted or solid? Dotted. Okay, maybe on your note card, you want to do this. Right? If it's less than or greater than, that's a dotted line. If it's less than or equal to or greater than or equal to, that's a solid line. That's, not huge points, but points that easily get forgotten. So you might want to write that down. Can you tell me where I need to shade for this? What? Above. If y is greater than, it's above that line. The other thing you can do is you can plug in 0. Is 0 greater than negative 3 times 0 plus 5? If you plug in 0, 0, it says 0 is greater than 5, which is not true. So shade away from the 0, 0, which would be this way. But really, the symbol tells you which way you can go. Y is greater than means go above the line. That would be above the line. Okay. The second one, I'm going to do this one in purple on mine. So y is less than 1/3 x minus 1. Where do you go first? Down 1. Okay. And then 1/3 means up 1 to the right 3. 1, 2, 3. Up 1 to the right 3 again. Solid or dotted?
Dotted.
This is dotted. And it says y is less than. Where do you go? Less than goes below, less than, like this. So your solution, your answer to this is the overlap, which would be this whole chunk right here. But I want to see all of it. Don't erase, okay? Okay, so with that in mind, you try B. Anyone want to come up here and graph it? Do you want to do it? You did it, but you don't want to do it. Brooklyn, want to do it? Tell us what you did.
Oh. So, I went up 6. Where's your backspace?
It's that. Undo that. Oh, you know what? You're on a highlighter right now. Okay, so up 6. And then she went down 1, right 1. Down 1, right 1. And then did you do a dotted or solid line?
Dotted.
That's a dotted line, because that one doesn't have the equal to bar. Okay, hold on. Finish the first one. Where do you shade on that first one?
Down.
Less than. Yep, so you would shade below. This one's a solid line. So that one goes up 2. Yep, and the overlap of those two things then is, yes, that top left corner. Does that make sense? Rise over run with your slope. Thank you, Brooklyn. Any questions on the graphing? So just make sure that I can tell that your final answer is overlap. Yeah. Yes. Will you leave your phone up here? Seabass, what are you doing?
I'm here to learn.
Oh, you know all this. Do you want to come teach it?
I would love to.
Oh, I would love to say you could, but I really got to get through a lot with these guys in the next few days. Okay. Let him do one problem? Is that what he said?
Yeah, one problem.
Oh, he could, but trust me, he's very smart in math. He does very well, but we're just going to try to keep powering through. All right, evaluating an expression. So x to the y power times z.
Can I get the answers?
It actually is, because we talked about it.
Sorry.
He's done. He's... So x to the y times z, you're just dropping numbers in. So this is 2 to the 0 power times negative 4, okay? What is something to the 0 power?
1.
It's 1. Anything to the 0 power, maybe you want to write that down as one of the properties. A to the 0 power is always 1, okay? Put that on your note card. Anything to the 0 equals 1. So 2 to the 0 power, that's 1, times a negative 4. So that's just negative 4, okay? You try B and C. Z to the x times y and z to the y times x. Let's see what those all are. What did you get for the value on B? 0? Let's see. So it's negative 4 squared times 0. You don't even have to figure out what negative 4 squared is, because anything times 0 is 0. So this is a value of 0. So if you go z to the 0 power times x, what does that equal? 2. This is 1. 1 times 2 is 2. Okay? Questions on that? Okay. How do you do scientific notation? Something times 10 to the power of something. You may want to write on your note card, scientific notation has to be like a number, point, whatever. You cannot have, this has to be between 1 and 10, not including 10, okay? It's got to be something less than 10, if you will. So like 9.23 times 10 to some power would be scientific notation, but 92.3 times 10 to the something power is not scientific notation. So just make sure you only have one number in front of your decimal point. And if you do that, then you'll be fine, okay? So take a look at this one. You have 3 times 10 to the 5th and 6 times 10 to the 8th. What do you have to do first? 3 times 6. So you're going to multiply 3 times 6 is 18. What do you do next? Right. These exponents are going to get added together. So it's 18 times 10 to the 13th power. Is that in scientific notation? No. You have to make it so that this number, 18, is a number less than 10. So you're going to move this 1 decimal point to the left, 1.8. Maybe you want to remind yourself of this some way too. If your decimal point goes left, then your exponent goes up. Okay? Maybe I don't know how you want to write that. If decimal point moves left, then your exponent gets bigger. Okay, whereas if your decimal point moves right, then what happens to your exponent? It gets smaller. Okay, so they reverse each other depending on which way you go. So this would be 1.8 times 10 to what power? The 14th power, because we moved it 1 to the left. Then think on a number line, you want to go 1 to the right. Khalees.
Is there any way to check this?
You could plug this into your calculator exactly how you see it, and then plug this into your calculator, and they should look identical. Right? If I type in 1.8 times 10 to the 14th power, I get 1.8E14 as my answer. If I plug the other in, I should get that exact same answer. If I plug it in with the parentheses, it should be the same. Okay, so try that one. Letter B. 12 times 10 to the 9th times 11 times 10 to the 9th. And what are you going to get? Plug that in. Yes. Do you have a phone? Do you have your phone? Whose phones do I have up here right now? Nobody wants them back?
I'll take them.
No.
Oh, that's kind of.
Oh, she's still in there. Wait till she gets back. Who was the other one then? Did someone not get their phone back? Is that your phone? Can you come grab it? Now you may go. Okay, so 132 times 10 to what power? The 18th. Okay. 9 plus 9. You're adding those together. That's not your final answer. What's your final answer? 1.32. So we moved 2 to the left. So you need to move this 2 to the right on a number line. So 2 bigger times 10 to the 20th. That is scientific notation. Okay? Questions on that? Okay. Things about simplifying. When I have something like number 9 right here, tell me some things that are not allowed. Negatives at all. No negative exponents. Okay, you cannot have a negative exponent. Do you know what other exponent you should not have left? A 0. What is anything to the 0 power? 1. Okay, so there's different ways you can think about this. C to the 0 being 1, I would do that right away because that just simplifies a lot of things. What happens with division? You what? By doing what? So you can flip it if it's a negative. You can move it to the other part. Or you can do what right off the bat right here if you want. What? Oh, yes, the C is fine. Yeah, I'm saying negatives. What do you do with a negative here? When you're dividing, this is division, right? You have a division bar. You could flip the A to the -4. You can't flip the 2. So then you'd have both A's on bottom. You can do that. What's the rule? Here, lay this out. A to the M over A to the N. If we're trying to simplify that, what do you do with the M and the N? You subtract them. This would be A to the M minus N. If I were you, I might go into your chapter 7 notes. Chapter 7? This was chapter 7. I'd go into your chapter 7 notes and I would pull up all of those properties of exponents and I would write every one of them on your note card. And you can write it in letter form like this, or you can write it with a number example. Like maybe you want to write it A to the 6th over A to the 3rd equals A to the 6 minus 3, which is A to the 3rd power. Okay, whatever makes the most sense to you. But I would write every one of those properties down so that when you see a division problem like this, you go, oh, division, I should subtract my exponents.
It's a property of an exponent?
Those are properties of exponents. Yep. And there were a bunch of them that we talked about. Okay. What?
Aren't those on the back of this page?
Yeah, they're just written in a slightly different format. Those will be on the final exam in that format. But if you want to put them like with numbers instead of variables, you could do that. Because I feel like sometimes that just makes more sense to people. Okay, so this being the case, look at just your A's right now. So some of you said we could flip it. We could move A to the 4th to the bottom, which is fine. You totally can. Then you have this. If you have that, what does that become? A to the 6th on the bottom. Okay, so you are more than welcome to do it that way. The other way you could do it is you could subtract them. It's -4 minus 2, which is going to put A to the -6 on top, which then you would move down to make positive, and you would get A to the 6th on bottom. So it is totally up to you which one makes more sense to you. I don't care. They both work. They're both great. Okay? What's going to happen with the B's? Move. You what? You're going to subtract them. B to the 3rd over B to the 6th is B to the 3 minus 6. So B to the -6 would go there. And you still have this C to the 5th on bottom. So right now we're here. That's not a final answer because we have negative exponents. Instead, you got to move those negatives down. So that's going to put A to the +6 on bottom. That's going to put B to the +6 on bottom. And it's going to leave the C to the 5th on bottom because that one's already positive. What does that leave us on top?
Just 1.
A 1. Khalees.
Restart.
Let's just erase it all.
Restart. Wait, what'd you get the B from?
It's because we did it 2 different ways in the same problem. Okay, I'm going to do it one way at a time. Yeah. Oh, it is B to the 3rd. Sorry. I wrote 6. My bad. Sorry. Sorry. Oh, so you're saying I'm the problem. I get it. No, I am. Did it wrong. Okay, we're going to do it one way at a time. Sorry for the confusion. We're going to stick with one method, and then if you want to see it the other way, then I'll show you the other method. Is that better? Let's do it that way. Okay, so the way the book, the curriculum would tell you to do this problem is because we're dividing, you should be subtracting. So look at your A's. A to the -4th divided by A to the 2nd is A to the -4 minus 2, which is A to the -6th. And that would be a numerator because you're always putting it as a numerator if you're just when you're dividing, right? It's like saying a to the m over a to the n is a to the m minus n. That's a numerator. Essentially, it's over 1, okay? You're taking numerator minus denominator exponent. -4 minus 2 is a -6. You subtract them, okay? You don't what? No, you always subtract them with division, right? We're dividing. This is a division bar, okay? Okay, look at your b's. B to the 3rd over b to the 6th. We're dividing. That would be b to the 3 minus 6, which is b to the -3rd. Again, that's a numerator. Okay. The c, I would just call this 1 right now. And then you have c to the 5th on bottom. Are you with me on that? Okay. Have I not messed up this time yet? We good? Sorry. Okay. So now this a to the -6th, a negative cannot stay in your problem. So to make it positive, you have to do what with it? Flip it, move it down. So a to the +6th, b to the +3rd, c to the 5th, but now there's nothing on top. When there's nothing on top, it's a 1. Okay? Okay, here's the other way you could have done it. Lost with what? Do you understand how to get here? Okay. Did you subtract your exponents? Right, so that's a -6. No, c on top? Because c to the 0 is 1. Anything to the 0 power is 1. No, yeah, anything taken to a 0 power is the value 1. Ava.
The one that you ended with, was it the one from the C, or is it just a one from like?
Yeah, essentially, sure, a 1 from the C. But if you've removed everything from your numerator, there has to be something there still. The something that will be there if you've taken everything away is always 1. Because 1 times anything is that 1.
Wait, so you can't end not in a fraction?
You could, but then these things would have to be in the numerator, but they're in the denominator.
Oh.
Right? So you could end with them in the numerator if it worked out that way. Like if I had,
I get it. Okay, yeah.
you good? Okay, yes. Sure, leave me your phone.
So do we not flip it? Like, you want it to be positive? I thought we flip it with C5 on top.
You are treating it as just a to the -6th. A to the -6th and c to the 5th are not working together right now. They are separate entities. Hey, excuse me. I can't concentrate with her if you're all talking over us. So you don't want to flip everything. You want to flip this as its own thing. So if it's a to the -6, think of it like this. It's a to the -6 over 1. You're just essentially flipping that so this moves down, but then there's nothing on top anymore, so the 1 is on top.
Okay, so if there's a Galactic denominator, like 2 and 5th, I'll just leave it.
It stays, yep, if it's positive, it stays in the denominator. Yeah. The positive ones stay put. The negative ones have to move to the opposite location. Okay? Okay, look at letter B. Do you remember what got done wrong on these a lot in class? I do. Here it is. You are taking everything to the 3rd power. But that means 2 different things, Jaden. You have to take 2 to the 3rd power and x squared to the 3rd power. What is 2 to the 3rd power? 8. It is not 2 times 3. But that's what a lot of people try to do. It's 2 to the 3rd. But x to the 2nd to the 3rd, which is what you're doing here, is what? That you're multiplying, okay? So you just have to be careful that you take this to the power, but when you take a power to a power, you multiply those numbers together. So maybe on your note card, you want to write something like, I don't know, maybe you want to write like 2x to the third is really 2 to the third times x to the third, which is 8. Oh, x to the third. Okay, maybe that is helpful to you. I don't know. It's however it makes the most sense to you, but make sure that you are taking it to the power, which means with exponents, you're actually multiplying. With numbers, you're taking it to that power. Okay, yeah. What x? It's right here. Oh, I was just crossing that out because I'm not done with the problem yet. We're going to come right back to that. Okay, so here's the scoop. We have taken 2 to the third power. What is x squared to the third power? X to the 6th, 2 times 3. What is y to the negative 4th to the third power? Y to the negative 12th. And what is z to the 5th to the third power? Z to the 15th. Okay, are we done? No. Several things you can simplify. What's the first thing you can simplify here? 2 to the third is a different number. It is 8. X to the 6th is going to stay put. What are you going to do with y to the negative 12th? That you're going to move down. So y to the positive 12th now. What are you going to do is z to the 15th. Leave it where it is, z to the 15th. And that will be your answer. Okay? How did I get what? 2 to the third power. So you're taking the number to that same power. So 2 times 2 times 2, or you can just plug that into your calculator. 2 to the third power. Brooklyn. It could be either. Okay, go to C. This one's very similar. We'll just do it together because we're going to run out of time. So there's 2 different things that are being taken to powers here. Okay? That first chunk is taken to the third power. The back chunk is taken to the second power. So you're going to cube these 2 things. So a to what power? 6. You're multiplying. 2 times 3 is 6. B to what power? Negative 9. Okay, now you move on to the next chunk. What does this become? 9. 3 squared. Okay, so it's 3 squared, or you can turn it into 9. I'll turn it into 9 in a minute. A squared to the second power is what? A to the 4th. You're multiplying. B to what power? The negative 8th. C to what power? The negative 4th. Okay, now we can combine. So this is 3 squared is 9. Look at your A's. A to the 6th times A to the 4th. What do you do when they both have their own base? You add them. A to the 6th times A to the 4th is A to the 6 plus 4, which is A to the 10th, okay? There's another property you might want to write down. So A to the 10th power. Put your, don't go yet, B to the 9th, C to the 4th on bottom, okay? Here's what I want you to do. For homework tonight, I want you to work through number 16 tonight. Okay, 10 through 16, 6 problems. Oh, and the D that we missed. Okay, and we'll pick up there tomorrow.